Dear students, and today we are going to see agglomerative clustering. So how to create the code. So here first we are going to import the libraries. So as you know, for NumPy, that is a numerical Python, and Pandas, as you know, that is for the data frame. And then this matplotlib and the cbond, which is used for plotting the graph, right? Okay, and then we are going for pre-processing. Okay, for pre-processing, we are using a standard scaler and a label encoder. Okay, so for data cleaning process and the missing data to fill and so on, we will see one after another what are the pre-processing methods we are using, right? And then we are going to import the agglomerative clustering method. Okay, so as I explained in the theory PPT, okay, just look at it. Okay, so now we will see about the coding, right? Okay, and then we are going to import the Silford score and Davis Boldin score and mutual info score. Okay, so mainly we are going to import all these things to measure the performance of the clustering. Okay, so for that, we are going to check the performance metrics. Okay, about the cluster, how much it is dependent with one another and what is the difference between the clusters. Okay, so likewise, we are going to find the property of the various clusters. Okay, how we are going to create it. And finally, we are going to import the dendrogram and single linkage. Okay, so how to draw the graphical representation of the connections between the two clusters. Okay, so first thing is first we are going to load the data set. So in which we are going to take iris.csv file. Okay, so that we are going to read it. For that, we have using this pd dot read CSV of iris.csv. This is the okay. So file CSV file we are going to read by using this particular function. And the next thing is, as I told you, for missing values we have to identify. Okay. So missing value either it can be like if it is an object, that means if it is a uh, numerical value, if it is missing, means we are going to find the, in a particular column, we are going to find the mean value of it, and then we are going to we are going to fill it. And if it is an categorical value, right? Or so likewise, if it is there, means we are not going to have a numerical value. So that is the time the maximum number of occurrence we are going to find out, and then we are going to fill the unfilled values, okay, in a particular column. So for that only we are identifying the mode here. Okay. So after doing this, we are going for encoding. Okay, encoding the categorical data. Okay, so how we are going to do that for encoding the categorical data? So over here, we are going to going for okay. So first we are going to convert if any categories, so that we are going to convert into the numbers. So for that only we are going to call the function label encoder. And then when we are using this particular function fit to transform, so here only we are actually converting all the categorical data from the data frame along the column, okay, into numbers. Okay, so that is how we are going to do that. Okay, so whenever you are having any categorical value, that we have to convert into the numerical value so that it will be easy for us to do the analytics. Okay, and the next part is we are going for normalization. Okay, so normalization means, as you know, you will have like a particular range. Sometimes, for example, age may be like a numerical value, the range will be different, and the year of experience for an employee, that can be different range. Got it? So maximum up to 25 if you are taking, means there the age can exceed up to 70, 80 likewise, right? So there will be a confusion if it is not in a correct range between two numerical column, so that we have to go for normalize. Okay, so normalization means between 0 to 1 or okay, so likewise we will give some range in which every columns we are going to categorize, right? So that is actually the normalization. Okay, so that's why we are going to do it. For that we are using this standard scalar. That is one normalization form. Min max is there. Okay, so in our example, we are using the standard scalar. Just we are calling the function, and then we are going to use as fit transform. Okay, for that particular data frame. Okay, along the column, we are going to normalize the every columns. Okay, so that's a df dot columns, right? So, and then finally we are going to do the dendrogram. Okay, so as you know, the dendrogram for the hierarchical clustering means the data points between the two clusters, which is very small. Okay, that means the difference, if it is very small, for example, here, okay, so between these two, okay, so that we are going to form the dendrogram. Likewise, after that, okay, the distance, the next smallest distance, we will just connect together. Got my point? So likewise, it will go, okay, so up to that, and finally you will end with only one single cluster, right? Okay, so this is actually the dendrogram of a single linkage clustering. Okay, so that only actually we are drawing here. Okay, so that's why we are giving the dendrogram here. Okay, so plot the dendrogram for the hierarchical clustering. Okay, so after doing the normalization, we are going for plotting the value. Okay, so we are giving the figure size as a 10 comma 5, and the linked, that is a linkage. We are method is single linkage only normally we will use. Okay, and then dendrogram linked, in which we are going to give dendrogram for single linkage clustering, that is a title, X label, Y label, and finally we are going to give the show, and then we will get the result. Okay, so this is drawing the dendrogram from the agglomerative clustering method. Okay, so here with the single linkage for performing agglomerative clustering, just we are giving the function name as agglomerative clustering, and so number of clusters is 3. That means what? The target, it may be the 3 category. See, in our example, you can see. Okay, so these are the 3 categories in which the cluster is formed. Okay, so that's why we are giving number of clusters as 3 here. So according to that, it is based upon the property, it will be clustered into 3 different forms. Okay, and then giving the linkage as a single linkage, and metric is Euclidean distance between the two data points. Okay, so that only we are seeing. For example, X comma Y means A and B can be the different rows. Okay, for example, like, okay, for each and every rows, the X and Y coordinate may be A comma B, and X and Y can be like a okay, so it can be like a training data. If you are going to find x minus a the whole square plus y minus b the whole square, the whole root. That only we are finding the Euclidean distance, right? Which is the minimal. So we are putting together as a single cluster, which has a maximum distance. We are making it as an another cluster, right? So likewise, we are going to draw the cluster and we are going to fit in it. Okay. So that is how we are going to do it. And about add the cluster label to the original data set. Okay, so to the original data set, we have to add these cluster labels as well, right? And then we are going to compute the cluster performance. As I told you, Silhouette, Davis, Mutual, all are finding the performance metric of a particular cluster. So Silhouette, what it is doing, so it is giving the difference between the clusters, Euclidean distance based upon that. Between the clusters, we have to find the distance. Okay, then only we can find out different clusters with the color code we are going to give, right? And then Davis Baldwin, that will indicate the lower value. Okay, so when you are finding the difference, the lower value when it is getting, then we can say that is the better clusters. Okay, so better clustering always have the lower value in finding the difference between the clusters, right? Or between the data points. And then finally, we are going to use the we are going to use mi square. Okay, so that is mi score that is used to measure the cluster dependency. Okay, how much the cluster dependency, okay, between the two clusters. If we measure, then only we can find out two different clusters. So it should be independent with one another, right? So that performance we are going to measure. Okay, so all these things we are just calculating, just we are calling the function name in which it is going to compute the performance metric of the clusters. Okay, and finally we are going to save the performance metric as well. Okay, so for that only we are using this performance metric data frame in which we are giving the metric a Silhouette score, all the different metrics we are going to give, and value is Silhouette, and then this one for this DB index and MI score. Okay, so that is how we are going to find the value of each and everything, right? Okay. And then finally, we are going for saving the clustering results and the performance metric, okay, for Power BI. Okay, so first, let us do this dendrogram and this one, okay, and single linkage clustering. And finally, we will go for it when we are doing the visualization process. That time you will understand. I hope this one you got a clear idea about agglomerative clustering. Okay, so do okay with your own data set so that you will get the clear idea about it, right? I hope you enjoyed the video. All the best. Thank you.